Let's look at the objectives of this session. We are going to discuss about introduction to C language, what is the C language program made up of, and we will look at some simple C programs. C is a general purpose high level programming language. We say general purpose because it can be used to create different types of programs or applications. C language was created by Dennis Ritchie in the year 1972. Now, when we talk about a language, these languages are high-level language. That means your machine cannot process them directly. So it has to be converted into a machine-understandable language. So to convert C instructions into a machine-understandable language, we use a system software that is a compiler. So that means C is a compiler-based language. Then, which operating system supports C language? See, many languages that are there, they are designed for some specific operating system. They can be, some languages work only on one operating system, some languages work on multiple operating systems. Now, if you look at C, C is supported by almost all operating systems. So if you have a Windows machine, you can write a C program. If you have a Mac machine, you can write a C program. If you have a Linux machine, you can write a C program. But one thing you have to keep in mind, the compilers will be different. That means when you are writing C on Windows, ensure that you have a C compiler for Windows. If you're working on Linux, ensure that you have a C compiler for the Linux operating system. Then, why are we learning C language? Why every college, university prescribes C language? C is considered as the soul of all programming languages, or you can consider it as the mother of all programming languages. Why? Because most of the programming languages that are there, they also need to have a compiler or an interpreter. So that compiler or interpreter is written in C language. That's the power of C language, right? Other system softwares like your operating system, your device drivers are also written in C language. That is how important C is. Now, what are we going to study here? We are going to learn C language for beginners. You're going to understand what are the rules you should keep in mind when you're writing a C language, what is C language made up of, what is its vocabulary, and so on. You learn the fundamentals of programming through C. That is what we are covering. C has many levels. So after this basic C, you have advanced C, data structures, then you have industrial level C, you have embedded C, you have many types of C language. So we are focusing on programming fundamentals with C language. Now, where should we write C programs on our computers, on a laptop or a desktop? So for that, you require an IDE. IDE stands for Integrated Development Environment. It's a software that you install on your computer. When you install that, you get an editor where you can write your code, you can save your code, you can edit your code, as well as you can compile it by using the compiler and run and test your code. So it's always better to do it with the IDE. We don't do it in Notepad and so on. We don't use simple editors. Now, which are the common IDEs available which you can use? The first thing is you can make use of code blocks. It's available for the Windows version as well as for the Linux version. A second is you can make use of Eclipse IDE. Then you can make use of NetBeans IDE. You have Borland C IDE. Then you can do it on VI editor inside your Linux or Unix. They are not really IDEs, but yes, you use that to create your C programs. So you have a variety of IDEs available. You can choose any one of them. For this course, I will be using code blocks, which is freely available on the internet. You can download it, install it, and start working on it. Now, when we start writing the C program, we need to know what are the things it supports. What are the rules we should keep in mind when we are writing the program. Every C program is made up of some words, which we call it as keywords, or you can call it as reserved words. You cannot use whichever word comes to your mind. You have to follow those words which are supported by C. So we call them as keywords. C supports roughly around 32 keywords. And it should be written in lowercase. So these are some of the examples what I have given for keywords. I have not mentioned all, only a few of them. So notice that I have written everything in lowercase. So your C is made up of keywords. Second, a C program is also made up of standard library functions. What are standard library functions? They are ready code. So somebody has written that code for you already. You can use that particular code or program in your program and get your work done. See, there are many things for which you don't have to write the code from scratch, right? So some things are readily available. We have to use it. You don't reinvent the wheel by trying to write everything on your own. So for most of the things, there are some readily available programs. We are dependent on that. We have to use that. So we call them as standard library functions. Example, you have printf, scanf, sqrt, pow, sign, cos, strlen. Notice that I have put parentheses for all these functions. That means library functions should end with the round brackets or the parentheses. And where are these library functions available? I said that they are readily available. Somebody has written it. Now, where is it available? When you install C, when you install your code blocks or any of these IDEs, the library functions also get what now? Installed. And they will be found in files known as header files. For example, if you look at sqrt, if you look at pow, all these mathematical functions, they are available in a header file called as math.h. Printf, scanf, they are available in stdio.h and so on. So the bottom line is all these functions are bundled in appropriate header files. That is what you mean by library functions. Next, a C program is also made up of operators and operands. What are operators? Your plus, minus, multiplication, division, the equal to symbol, the percentage symbol. Then we have plus, plus, minus, minus. There are a lot of operators. So we will be using all of them frequently in our programs. And what are operands? So you saw in the flowcharts, we used variables, right? A equal to 10, pi equal to 3.142. So all these variables, we call them as operands. Even the values are also called as operands. For example, if I write C is equal to A plus B, then A, B, C are called as operands. If I say C is equal to A plus 8, 8AC are also called as operands. So our C program will be made up of these operands and operators. Next, we need to understand something called as data type. What is data type? The meaning is very simple. The type of data what you use in your code. What are they? We classify them into two major types. One is known as the primary data type and the next one is secondary data type. A primary data type is divided into int, float, double, character, long, short. What are they? Let's look at it. Now, when I give A equals to 10, 10 is a data which I'm assigning it to the variable A. But in C, I cannot just start off with A is equal to 10. I need to tell the variable which I use can contain what type of data. So when I say 10, 10 is a number, and to be more precise, it's an integer or a whole number. So we say that 10 is an integer. That means A also becomes an integer, means it can hold integer value. Float. If I say 3.142, this is called as a float, and this float has got 6 digits precision after the decimal point. If you want more precision, then we use double. For example, 3.142, 168, So that means 3, 6, 9, 12. 12 digits precision after the decimal point. Depends upon what you want. You can use one of them accordingly. Next is the character data type. Our program will not be made up of only numerical data. We will be dealing even with non-numerical type of data, which we call it as a text or we call it as a character. So C supports character data type. What are they? Like anything from capital A to Z, small a to Z, symbols like dollar, hash, all of them come under your character data type. Next, secondary data type. Secondary data type is made up of array, string, structure, union, pointer. You will understand these only when we come to those topics or those sessions. So this is just like a classification what I have given. We will discuss about them later. Okay, so now we understood what is a C program made up of. Then, when we write the C program, you cannot write the statements however you want. There are predefined sections. You have to follow them. So let's look at that. So we call this as a structure of a C program. A C program has the following sections. At the top, there is a section called as preprocessor directive. What is this preprocessor directive? You will understand it when I take an example. So just keep in mind for right now that the first section is preprocessor directive, followed by the main section. Then third is a declaration section and the code section. Let's start with converting our first flowchart to C program. Let's revise the flowchart. So this flowchart is to find the sum of two numbers 10 and 20. We have assigned 10 and 20 to two variables a, b. Then c is equal to a plus b, print c and stop. Let's see how to do this in code blocks. So I will launch code blocks. You can see I have code blocks over here. Let's start this. This is the environment of code blocks. Close this first tab over here, start here, close this window. Go to the file section, new and empty file. The other way is you can just click on this icon also. Both are okay. Now the first thing you do is you save your file. So this program is to find the sum of two numbers. Let's save the file with the relevant name. So go to your file option and say save file. Now since this program is to find the sum of two numbers, I'm going to give the file name as add.c. The file name has to end with .c. This is important. Okay. Now you can see some line numbers over here. Line numbers are not a part of a C language. This is only for us to help in keeping track of the number of lines we are writing. Now the first section of your C program begins with the preprocessor directive. So I'm going to start my code with #include stdio.h. Why should I give this? I will come back to this in a few minutes. Next, followed by the section called as int main, round brackets, enter, put a pair of curly bracket. It should have an opening and a closing curly bracket. Most of the IDEs will do that automatically for you. But some IDEs will not do that automatically for you. So it's your responsibility to put the closing curly bracket. Okay, now inside this curly bracket, we are going to write our C code. Now, the first section, if you remember, I told that it is made up of declarations. Now, what do we mean by declarations? If you look at the flowchart, we are using three variables totally. Now, in C, what we have to do is, in the beginning itself, we have to tell how many variables we are going to use in our entire program. Those variables could be for assign, they could be for calculations, they could be for print, anything. But you should declare them in the beginning. Declare means you need to tell very clearly to your C compiler that how many variables you will be using and what are their data types, right? So what is this terminology known as? It is known as declaration of variables. Remember this. So how many variables I'm using? Three variables. What are the values I gave for A and B? 10 and 20. Now, 10 and 20 are what data type? They are integer data type. That means when I'm declaring the variables, I also have to tell what data type it is going to hold. So my code is going to be like this now. Int A, B, C, and the line has to end with a semicolon, right? And also see to it that I'm not writing this int exactly below the curly bracket. If you write it, also it works, but it is not good programming. Put a tab space, give some space at the beginning of the line. This is really important. This is considered as a good practice. Now, press enter. Now, assign the values. So, I finished with the declaration. Now, my actual code is to assign the value. A equals 10 semicolon, B equals to 20 semicolon, next C is equal to A plus B semicolon. Now, what did we do in our flowchart after calculation? Print C. Now, I need to do that. So, how do I do that print? C does not have a keyword to print. Then in that case, how should I print? Now I am dependent on a standard library function. So the standard library function we are going to use is printf. Okay, how do I write it? Printf in lowercase. Printf, round brackets, double quotation. Now we use something called as format specifier, that is %d. What is this %d? Now printf is capable of printing different data types. You can print an integer, float, double, character, and so on. So now I need to tell my printf which variable I'm printing and what is its data type. So for that we have to say printf %d, comma, which is the actual variable is C, and end this with semicolon. So I will repeat, you cannot just say percentage %d and leave it. This is not correct. Nor can you say printf c and leave it. This is also not correct. So you have to say percentage %d, double quotation, then outside the double quotation, comma and c. Now my program is ready. Since I made changes to the file, my first step is to save the file again. Click on the save icon, or you go to your file and menu and select save. Any one of those methods is okay. Now my program is ready. Can this be directly processed by your computer as it is? No. We need to convert it into machine understandable instructions. So for that, what do? We have to use a C compiler. So now what I'll do is I will convert my C program into machine understandable language. How do I do that? So go to your build menu over here. Can you see this build option? Click on this build and you say compile current file. Or there's a shortcut. You can also use a keyboard combination Control Shift F9. So I will now use compile current file. Now what happens when I say compile? It will check for all the instructions that I have written. It ensures that I have not violated the rules of the C language. If everything is fine, then it will convert it into the machine understandable language. But if I have made any mistakes, then it's not going to compile it. I have to fix the errors. Let's do this now. Go to the build option, compile current file. Press F2 to see the result of your compilation. So here at the bottom, you can see now, it is showing it as 0 errors. So that means everything is perfect. So close this F2 window, what we opened. Click on this close button. Then execute your program. Execution means your code will be processed and you will get the result. So for that, what do? Go to your build option. Then you have run. So click on this run. So you can see the answer as 30. This is your result of the first program. Let's understand the code of this program. So I initially used #include stdio.h, which is a preprocessor directive. Why did I use this particular line? See, printf is a standard library function. That means it's a readily available program. And that program is available in the header file called as stdio.h. stdio stands for Standard Input Output Header File. It contains lot of functions which are related to input and output of a program. I knew that printf is available in this header file, so I included it. Now, as we proceed further, you will be using lot of library functions and you should know which function is available in which header file and you have to include that. So, your preprocessor directive can consist of multiple #include. Okay. So, that is the reason we included stdio.h. Next, let's look at this %d. This %d is known as format specifier. What is this format specifier? I told you that it is meant for the printf to know that it is printing an integer. There are other format specifiers. %d is to print an integer. %f is to print a float value. %lf is for printing a double. %c is for printing a character. %s is for a string. Let's understand data type rules along with expressions. So we will discuss these two things. What are the data type rules? It's like this. If you add two integers, the result will be an integer. Integer minus integer is an integer. Similarly, integer into integer or integer divided by an integer is an int. Let's take a small example. 2 plus 3 equals to 5. So, int plus int is an int. 2 minus 3 is equal to -1. -1 is also an int. 2 into 3 is equal to 6. 6 is also an integer. But now suppose I say 5 divided by 2. 5 and 2 are integers. The answer should be 2.5, but it will not give it as 2.5. It will just give it as 2 because that is the rule. An integer divided by an integer, the answer will always be the integer part of the result. So 2.5 is cut off. It will consider only 2. So you need to be careful about this when you are writing your formulas. So sometimes you will see some unexpected result. Why? It is because of such things. Then how do we handle this? 5 by 2, I should get it as 2.5 only. In that case, what you have to do is you have to ensure that one of them is a float. So now if you look at it here, I have written a second set of steps. Integer plus float is a float. Integer minus float is a float. Int into float, a float. Int divided by a float is float. Or float by an int is also float. So that means if any one is a float, the result is always float. Similarly, look at float and double. Double is having higher priority compared to your float. So when you do float plus double or float minus double and so on, the result will be a float. Similarly, int and double, the priority will be given to a double. Now coming back to this, I want interested in this division now. So if I want 2.5, I have to ensure that one of them is a float. So 5 divided by 2.0. Now this will be 2.5 because it's a float. It's going to add 6 digits after the decimal point. So 2.5. Or you write it as 5.0 divided by 2. Also the answer is same. You want 5.0 divided by 2.0. Also the answer is same. Or you can also do it like this. 5 divided by, inside the brackets you give float 2 is equal to 2.5. You can use any of these methods. The last method what I have written float of, this is known as typecasting. This is known as typecasting. What is typecasting? Converting one data type to another data type is known as typecasting. So remember these points. When you're writing the formulas, ensure the rules. Okay, this is one point. Next, let's understand the terminology expressions. An expression is something like this. C equals A plus B is an expression. X is equal to A plus 8 into 2 minus 3 is an expression. So we don't call it as a formula, we just call it as an expression. Now, an expression is made up of operators and it is made up of operands. Operators and operands. What are operators? Plus is an operator, equal to is an operator. Then in the second one, equal to, plus, into, minus, these are called as operators. What are operands? The rest of the things are operands. A, B, C, operand. X, A, 8, 2, 3, they are known as operands. So an expression is made up of operators and operands.